Hello everyone, welcome to Learn Overflow. In this video, we'll discuss this LeetCode problem that is the power of 3. So this is an easy type problem and we'll understand how we should think of finding a solution of this kind of problem. Also, we'll discuss three different solutions and if possible, we'll run them all to find a solution of this. Okay, so before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says, given an integer n, we should return true if it is a power of 3. Okay, so we are given an integer n. If this integer is a power of 3, we should return true, else no, false. Okay, so power of 3 in the sense n equals 3 to the power x. Okay, so that's n. There should be some x existing. Okay, so like 27 is power of 3, so it's true. 0 is not a power of 3, false. So 9 we know is power of 3, it's true. So that's the idea. Now look at the constraint. It's really important. The constraint is like uh it goes up to 2 to the power 31 minus 1, and in the backward it goes up to minus 2 to the power 31. Like n goes like this. But something you need to know about that is like if like minus anything less than 0 or less than 1, like less than 0 cannot be power of 3, right? That's not possible. So all the negative numbers are, we should be careful that if our n is less than 0 or n is less than 1, we should take 1 as well. Is okay. So if n is less than 1, we should know that that's not in our range. You shouldn't go ahead check for anything. That's directly a false. Now how we should go ahead and find that this is in the positive part. Okay, so the first thing that should come to your mind is like we should keep on like there should be a loop. In that loop we should keep on dividing our keep on trying to divide our n with 3, and if the remainder is 0 we should divide it. If the remainder is not 0 we should stop that and check whether we have reached 1 or not. Just in simple ways, if I just write down the code in like 2-3 lines, look what we can do exactly. Now, look here, what exactly I did. The first thing was if n was less than 1, it should return false, because remember the n was 0 and it says it should be a false. So, and we know the negative not possible. So we know that n is less than 1, it should return false. We got our first case. Next, we are checking like if we are trying to divide, and if we're checking if the remainder once n is divided by 3 is 0. If our remainder is 0, we should divide n by 3. So we are keeping like continuously dividing n by 3, and after that like if any case anyway we find that n is not like n is leaving a remainder not 0, which is not 0, what can be the other remainders when we divide something by 3? The other remainders can be 1 or 2. Fine. So if it's not 0, then we should check if our remainder is 1. Like if we have reached somewhere that where n is already become 1. Okay, if n is 1, that is n is less than 3, it will remainder will be 1, right? So if we reached 1, that means we know that it's a multiple of 3 and it's a power of 3. N was initially a power of 3. Fine. And in the other case, if n is not 1, that means it reads something like 2. The remainder reads something like 2. So that means it's not our case. Uh, we shouldn't go ahead with that further. So that's the whole idea. Fine. Now, if we just run it, you will see it works pretty good. Fine. Now, what can be the situations? Okay, what can be the situations? Now, you need to know something that if we're doing some kind of test like this, so what can actually happen? So we need to check for something. Say we are given a number that is huge, because we need to check for 2 to the power 31. Fine. If a number is pretty huge, then what happens? A pretty huge, what can be? We are given an integer number, right? So here we know it's an integer number. So what can be the highest integer? 2 to the power 31. Okay. And what can be a number like power of 3 near about 2 to the power 31? So power of 3 near about 2 to the power 31 will be 3 to the power 19. Okay, so 3 to the power 19 If we just check about that 3 to the power 19, it will be some digits, something like this. This is the number that comes up. And if you check for 3 to the power 20, you will find that say 3 to the power 20 is going above 2 to the power 31. Like this like range of int we have. Fine. So 3 to the power 20 will find that is going above the range of int. So that cannot be a value. So what can the maximum case that happen? The maximum case that happen is like 3 to the power 19. So this loop, if possible, will run up to 19 times. Okay, that's fixed for you. Now, so we know pretty well that this won't be a huge time complexity question, and if we run it, it won't give you a much larger time complexity. See, it's just 19 millisecond time complexity is given to you. Okay, can we improve this? Now the question is, can we improve this? Now, once we know that we are given an integer and we the maximum case that can go is 3 to the power 19. Okay, so in that case, can we directly say if this 3 to the power 19 is divisible by our n, okay, and it leaves a remainder 0, then isn't it our solution we are looking for? Why I am thinking of this kind of solution? The idea is the follow-up question is given to us: can we solve this without loops or recursion? We solve this using a loop. Fine. Can we solve this without a loop? Let's say. So the idea is, if we just research on it, we will find that 3 to the power 19 is a huge number, and that is the largest number that can be like that can come in integer range. Fine. So if we are given an integer range and the largest number can be like this, can I modify this to our solution we are looking for? Exactly, if I want to say you what I mean, it's like we have our largest number. Fine. Can we simply say if our this largest number is divisible by n without any remainder, then that's our answer. That means see what can happen. It is like n is something that is either 3 to the power 19 or less than 3 to the power 19, like in the sense that if it's a power of 3. Fine. So if we divide this with our n, then it should give us 0. Anyways, it's a power of 3 and it should leave a remainder 0. If it's not leaving a remainder 0, that means it's not in the power of 3 we're looking for. Fine. So why don't we modify it simply and try to do it? Okay, fine. So let's erase this off and simply modify this. So this is what we are exactly looking for. Fine. Now, in this case, see, it works. It works correctly. So what we try to do, the idea is simple. Okay, we try to divide our 3 to the power 19 with our n. Okay, and if we divide this number with our n, and it is leaving a remainder 0. If it is leaving a remainder 0, that means we directly know that uh, this is an power of 3, because some power of 3 is dividing our largest possible power of 3 and leaving a remainder 0. That means it's completely dividing. So it's directly we can say that this is a power of 3. So if we just try to run this, okay, see here we are not using any of the loops or something like that. So if we try to run this, this takes us some around 23 milliseconds. Fine. I don't know why it's showing this kind of complexity, but it shouldn't be more than 19 actually. Anyways, so this is more or less the idea should be. We should go ahead. Fine. Look, I think there's some issue with Britcore judgment, but it immediately went down to 15 milliseconds. So I don't know about this, what the judgment they are making. But see, we are not using a loop. We're directly checking if our largest number is somehow divisible by our number given to us, and without leaving any remainder, then it's a power of 3. So that's the whole idea. Fine. So that's the whole idea, and I hope it's understandable to you. And this is a simple method which you can use for other prime numbers as well. Okay, so other prime numbers in this is you can use for 2, 3, 5, 7, 11, 13. For any of those numbers, you can simply use this kind of numbers. Okay, So this kind of technique. But remember, this is not a technique you can use with composite numbers like for 4, for 6. This is not a process you can do it. Okay. So that's the whole idea. So I hope it's understandable like how you can like improve your code with this. Okay, you are using without using loops and recursion, how you can go ahead with that. So that's more or less about this question, guys. So I hope I can make you understand this question. If you still have any doubts, make sure to comment them down. I'll be happy to help you out with that. So that's about it, guys. Thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.